Hello, good morning to all of you. A very warm welcome to today's session about G3-PLC. I hope you can hear me. I can see my fellow panelists, and I hope all attendees can hear me, but I'll trust on that. My name is Leon Vergeer, and I'm the General Secretary of the G3-PLC Alliance. And under normal circumstances, we would now be in African Utility Week promoting G3-PLC. But as the conference has been postponed, we are very glad we have this opportunity today to talk with you online. And for today's webinar, we specifically invited representatives from utilities in Africa to answer any general or technical questions you may have regarding G3-PLC. And we are very pleased that we have representatives from 8 different countries in Africa joining us today. So that's very nice. Thank you very much for that. And first of all, let's move to other people joining me in the session today. That is Marc Delandre from Enedis in France and Cédric Lavenu from EDF R&D. Marc, Cédric, could you please briefly introduce yourself, please?
Hello, good morning, everybody. I am Marc Delandre from Enedis. I have been working within Enedis for an EDF group for over 30 years, and I am also the chairman of the G3-PLC Alliance, and I will be pleased to give you some information about G3-PLC in the world, in France, and to answer your question.
Thank you.
So good morning, everybody. So my name is Cédric Lavenu. I'm expert research engineer at EDF R&D, which is a company I joined about more than 10 years ago. And I've been always working in the field of power line communication, also other telecommunication solutions, and involved in different standard organizations, and more specifically G3-PLC Alliance as a chair of the technical working group. Thank you. Welcome to
it. Thank you. And as I already mentioned, my name is Leon Vergeer. I started working for the G3-PLC Alliance in 2014 in setting up the certification program for the Alliance. And before that, I worked with utilities in the Netherlands. Let me see. In this webinar today, we planned a discussion around 3 topics. I will start explaining in general about G3-PLC and the G3-PLC Alliance. And then Marc will tell you about mass rollout of G3-PLC smart meters in France. And after that, Cédric will explain about performance, enhanced grid operations, and hybrid PLC RF communication we are developing. We received quite some questions from many of you before the webinar, so thank you very much for that. And in this presentation, we will also address these questions right away. If you have any questions during the discussion, please post them in the webinar tool. Then we will try to answer them in the Q&A session at the end of the webinar. And if you want, you can post your questions in France, as we have, as you know, had 2 people from France. And after the webinar, we will also share with all of you by email the presentation we made today. We plan to finish at 6, or no, in 1 hour, so it's 12 your time. So let me first start with a general introduction to G3-PLC. G3-PLC was developed from the start for mass rollout of smart meters, and specifically for the 35 million smart meters in Enedis in France. So G3-PLC has been designed to work in challenging, noisy grid environments. A number of characteristics are summarized here in this figure. It's a cost-effective technology because DSOs use their own infrastructure for telecommunication. There are no telecom fees to be paid, and there is no dependency on telco operators. It's an open ITU standard. In 2012, the specification was published by ITU as an official international standard, and it's being used worldwide currently. G3-PLC embeds all modern features for long-term network operation, for example, including IPv6, high robustness. It operates at different modulations depending on the conditions in the network, and it's self-healing technology, and we'll further talk about that later. Secure, it has state-of-the-art security. G3-PLC embeds all features to ensure confidentiality and integrity, like authentication, encryption, and anti-replay mechanisms. On the right side, you see a couple of applications for G3-PLC. The main application is still smart metering, but G3-PLC is also being used in other applications such as street lighting, home automation, in railway control systems, and several other industrial applications. So the benefits in general of G3-PLC are there is no dependency on telcos. It's low cost as you use your own grid. It facilitates long-range communication. It has high indoor penetration, and it enables enhanced grid operation because as a PLC technology, it is naturally connected to your grid. And we will come back to that later in the presentation. The G3-PLC Alliance, it's a non-profit organization founded in 2011. And it's backed by an international group of DSOs and industrial players to ensure continuity and evolution of G3-PLC technology. And currently we have over 90 members in the Alliance. One of the most recent new members is the company called ST, which is the main utility in Latvia in Eastern Europe, and they are installing 1 million G3-PLC meters in their grid at the moment. And these are all the logos of all the member companies. G3-PLC is a mature technology. Currently, we have over 50 million devices in the field all over the world. As I mentioned, it's an open standard, so anybody can use it. Our members, they often compete in the market, so they do not always want everybody to know where they do pilots and rollouts in the world with G3-PLC. So as G3-PLC Alliance, we do not know all the implementations there are over the world. But on the map here, you can see the pilots and rollout we do now. We have a strong certification program which opened in 2014, and certification guarantees that certified products actually implemented G3-PLC and they are conform to the standard. Certification guarantees that the product is interoperable with other certified products and that the product meets specified performance levels. And up to now, we are running the certification program for 5 years, and we have almost 400 different certified devices, which are all listed on the G3-PLC website. Now, one of the questions asked before the webinar was, how does the future look like for G3-PLC? Well, like I mentioned already, we have an active group of members who are continuously working on technological enhancements of G3-PLC, so the technology keeps evolving. We work hard to further increase application of G3-PLC in smart metering, for example, in Asia, Eastern Europe, and of course, we hope it will be widely used in Africa. And also, we will focus in near future on application in South America. Besides metering, we will further develop applications in other areas like street lighting, industrial automation, and railway applications. And then another important next step for G3-PLC is developing a hybrid PLC RF solution to maximize the coverage of the technology and to open up new use cases. And we will also talk about that in more detail a little bit later. So G3-PLC is a proven and robust technology, but we keep evolving and expanding globally. Now let's take a first look at a few of the questions which were already shared before the webinar. This is the first one. There was a question about what features are built into G3-PLC to overcome EMI in power networks, and what are advantages of G3-PLC over legacy PLC technologies. Cedric, I think you are best equipped to explain about that.
Yeah, so basically, we have to keep in mind that G3-PLC has been designed for noisy networks. So by nature, it integrates channel correction, error correction mechanism that makes it suitable for harsh channels. There are two mechanisms in particular I would like to highlight here. The first one is channel estimation, which is done by neighboring nodes, G3-PLC nodes, that will estimate the attenuation and between or to the neighbor node, as well as the noise level it receives. And from that information, it's then able to basically use the carriers that should be used and not use those that are, for example, let's say submitted to a too high level of noise. So that is really a very useful functionality to be robust against noise. And of course, the modulation is also adapted with respect to that. You would use more robust modulations where you have strong noise, and you would use faster modulations where the channel conditions are good. In addition, there's also what we call interleaver, two-dimensional interleaver. So behind this very technical word, the principle is to say that we would use both time and frequency diversity by basically repeating the information in the error code and error correction code to spread it over time and frequency. So when one information is sent, you can always find it at several places in both time and frequency, which makes G3-PLC very robust. And these features are advantages G3-PLC offers.
Okay, I hope that explains a little bit about the advantage of G3-PLC in particular. A second question we received before the webinar is regarding FCC band plan usage in Africa. What should African utilities consider when deciding to deploy FCC? Can you migrate from Senelec A to FCC? And what about radiated AMI regarding FCC? Cedric, can I ask you again to address that?
Yeah, thank you, Leon. So here we are purely in a regulatory question. In Europe, using FCC is not explicitly authorized, but it's not even explicitly prohibited. So basically, when we deploy, for example, FCC in Europe, we just make sure that we do not encounter any regulation issues with local regulators in the different countries, in different European countries. And I think that's exactly the same approach you should have in Africa, to make sure that there is no local rules that would, let's say, prohibit you from using the FCC band plan when communicating with PLC signals over the network. So that's really what should be made clear locally. And of course, there's probably as many regulations as there are countries. Nevertheless, personally, I've not heard about any issues up until now about this deployment. Also, my advice would be, of course, to use FCC wherever it's possible, because it simply offers a wider data rate than Senelec A. But of course, Senelec A is also an option that could be considered. In any case, when we talk about migrating from Senelec to FCC, if this is a scenario or strategy you would like to apply to your local deployment, that it's not always possible. It's a question of the meters you would buy to your manufacturer. The G3-PLC alliance do not specify the mechanisms that should be implemented in meters. Nevertheless, I know that some equipment manufacturers could offer this type of features and others do not. So some meters would not, you could not just switch them from Senelec A to FCC, and you'll probably have to replace them. And some other meters, you may be able to do this switch. So really, it's a question to make sure with equipment manufacturers whether you have FCC ready options that could be deployed in the future. Regarding the EMI cases about FCC, it's also a little bit related with the first question of what's the regulation, what the local rules. To me, I have not heard about any EMI cases that have been reported for the FCC band plan. I mean, radio services in general in that band might not be affected that much because, of course, the frequencies we use are still have still long wavelength, and the network is not an optimized radiator at these frequencies. So this is really something that should technically not be an issue. And but of course, again, we have to check with regulators. And in the worst case, it's always possible to turn off some interfering carriers thanks to some features, the tone masking feature in the G3-PLC standard. So you always have the option to go that way if you need to. Hope that was clear.
Yeah, and if it's not clear, or when you have additional questions, please share them over the webinar, then we can address them right away, hopefully. Then one final question before we move to the presentation about Enedis in France. There was a question specifically for South Africa, I think, regarding customer interface units and how they should be connected to the meter. For good performance, they should have peer-to-peer communication. Is it possible to have the meter act as a PAN coordinator for the customer interface unit and at the same time as a PAN device in relation to the data concentrator for the metering? Cedric, I turn to you.
Yeah. So first of all, a meter is a device, and here we will talk about the implementation of a PLC modem. So a single G3-PLC modem could only operate either as a PAN device or as a PAN coordinator, right? So an implementation, a protocol stack can only have one of the two roles. Nevertheless, a meter could also implement two stacks, one being the PAN device and one being the PAN coordinates, like you have two modems. So that's of course theory. That's of course practice, and in theory it could also be possible. I think that a manufacturer develops a stack that could be configurable or in real time, but I have not known about such implementation. So really the message to keep in mind is have two modems in a single device to ensure that you would have this operation. So that's our recommendation. It's also while we discuss about separating the two paths toward the data concentrator outdoor and the custom unit inside the house, it's important also to separate frequencies as much as possible. For example, you could use Senelec A for the communication with the customer interface, or Senelec B, for example, recently issued a new certification program, or and basically use FCC to the data concentrator. So you really this separation would allow a much better coordination between the two networks without any interferences. That's what we recommend.
Okay, I hope that clarified to the audience. Then let's move to the second part of the. We want to present it specifically about the rollout of G3-PLC meters in France. Mark, if you could explain, please.
Okay, thank you, and thank you, Leon, and good morning, everybody. And I hope you will hear me. And I think and I hope that in November it will be we'll be able to have a face-to-face meeting in South Africa. But today's situation is quite difficult. Regarding the rollout of Linky, Linky is the name of the smart meter in France. It's only a PLC power line communication smart meter, and we have decided to replace all the meters in France. That's to say 35 million meters to be in the field before the end of 2021. We started the massive rollout in December 2015, and it will take 6 years. Why 6 years? Because it's a big logistic issue to replace 35 million meters. It means, in average, 5 to 6 million meters per year. The total estimated cost for the operation is more or less 5 billion euro. But it's difficult to compare the cost in France to the cost in any other country. The main part of the cost in France is due not to the meter itself, but to the cost of the workforce to set the meter in the field. And thanks to this operation, we have created in France 10,000 jobs, partly for the design and the manufacturing of the meters, and partly for the operators in the field. We are working with 6 main partners. You can see them on the slide, and among them Sagemcom and Landis & Gyr, who are 2 of our main partners. Sagemcom is providing both data concentrators and meters, and Landis & Gyr is providing meters. We started the rollout in 2015. It works fine, and it will be a very big improvement in the network management, and we will have to manage on a daily basis 3 billion data sets used not only for smart metering, but also it's a good way to develop network services thanks to this kind of information. Leon, can we switch to the next slide, please?
Yep.
Okay, thank you. Today we have 24 million meters in the field, working very fine. It's, as I said, it's only power line communication. At the beginning, we started with G1, the first generation of power line. G1 is SFSK technology, it works fine, but G3 is better, and we decided to switch to G3 technology. And at the end of the rollout, we will have almost only G3-PLC meters. We have to provide 700 to 800 meters per month, and the performance is quite good. The data collection rate on a daily basis is over 98%, including all the events on the chain, not only the power line, but the GPRS communication between the data concentrator and the end system. And regarding remote operation, it's almost 100%. It's over than 99%. It's quite good, very competitive, and it works fine, whatever the type of network in France, in big cities, in rural areas, in areas close to the sea, in the mountains, and whatever the weather. It's a very robust technology, and even if the level of noise on the network is high, it works fine. So it's a good demonstration, and we are proud to promote this technology worldwide.
Thank you, Mark. Yes, there was one question, Mark, I hope you can address. That was, what steps should the utility follow for successful rollout of G3-PLC networks? For example, is it necessary to do noise measurements? So I hope you can address that.
What I would recommend, for sure, it's always interesting to make some noise measurements, but as Leon said, today G3-PLC is working in over than 30 countries, and we don't have any issue with noise, but you can do it, and perhaps you can start with a small, not a POC, but a small test with 1,000 or 2,000 meters in the field to double check everything, and to be sure your operators have the good skills, the right skills to do meter installation. My main recommendation regarding a big rollout, because the big issue is logistics. If you have to install in the field millions of meters, you have to organize everything. You have to work with customer acceptance may be an issue. And in France, we didn't have any technical issue, but only issue regarding customer acceptance with different types of questions, such as we have to pay for the smart meter or not, some question about privacy, about security of data, and so on. So you have to explain everything to the customer upfront in advance to welcome the smart meters. Then regarding the rollout by itself, my main technical recommendation would be first to start with the installation of data concentrator, and then in the second time install the smart meter. And then, as the technology is based on PLC and meters are repeaters, I would recommend to complete as soon as possible an area to be sure to have a very good level of performance. Then regarding noise, it should not be an issue. It works in European countries, it works in China, in other Asian countries. It has been tested in different countries in Africa. It works. And regarding the frequency band, you could have the question Senelec A or FCC. And as Cedric said, first, it's a matter of regulation. In France, we have to use Senelec A, but my recommendation on a technical point of view would be to use FCC because the bandwidth is better, it's more powerful, and regarding noise is probably also better. So recommendation regarding the band FCC for sure.
Okay, I hope that answered the question regarding the rollout specifics of G3-PLC. Let's continue. I have one question, but I'll address that one in the next topic. When we talk about performance enhanced grid operations and the hybrid PLC RF I mentioned earlier. So Cedric, I think this is for you to explain a little bit further.
Yeah, thank you, Leon. Indeed, there's one also topic, a question that was brought up by different attendees. It's the question of how will G3-PLC performance, let's say, depend on the configuration of the network. There's the question, of course, of how many smart meters you have for each DC, and probably other factors such as the geographical distribution of the different nodes over the grid. So this is clearly to be looked at, and what we can first say is that G3-PLC was designed to handle several hundreds of meters per DC. That's perfectly feasible using G3-PLC. As a matter of fact, the largest substation Enedis manages has actually 1,200 smart meters. It's true that this is a quite, let's say, rare case, right? That they typically there are, I mean, a medium average number would be 50 meters per DC in France, but of course we would have a certain number of substations where you would have 100, 200 meters, even 300, 400 to 600 meters. What I know from that is that you can always, we always have the experience to make G3-PLC work either in its default configuration, or sometimes for the bigger networks, we could eventually tweak it a little bit, playing on the different attributes. Nevertheless, the Alliance and Workshop 1 in particular is currently working to further improve the performances, and more particular the available bandwidth in dense networks. And I would say the dense networks would really start above 300 meters. Below 300 meters, I would say there's no real issue. Of course, if you have both a lot of meters and a lot of noise, of course, it could be a little bit more challenging. But G3-PLC is designed to do that without any problems. So the recommendations we could still, let's say, issue here is that the stack configuration, we should make sure that routing tables have extended time to live, right? Once a route is constructed, you have a routing table entry. Well, it's better to have a 24-hour time to live, for example, than a 30 minutes time to live, where you would need to reconstruct the routes every time you kind of interact with one particular meter. It's recommended basically to lower down the number of messages you would need to send to construct this route. So really have as much the longer time to live, the better it is for the routing table. And the same way, sometimes something that is forgotten is also that when a smart meter associates with a G3-PLC network, it's advised that this meter stays registered to this PAN as long as possible. Also, would be nice to have maybe 2, 3, 4 days of registration active before it eventually decides to go away from that PAN and find another one. So that's a clear recommendation. Also, application process and traffic patterns need to be optimized, right? It's for example, if you have 10 messages to send to each one of 100 meters, it's basically better to send 10 messages to meter 1 than send the 10 messages to meter 2 and not send one message to meter 1, the same message to meter 2, 3, 4, up to 100, and then again do it again. You would lose a lot of bandwidth doing that. But there are really some engineering tricks we need to basically use, and this is also partly described in the user guidelines that are currently published by the G3-PLC Alliance, and namely upper layer integration with G3-PLC. Right. These are some first hints. On the next slide, if we can switch to the next slide. Thank you, Leon.
Yep.
So also something that is interesting. So it's about the registration of the different devices on the G3-PLC network. It's important to avoid any type of, let's say, simultaneous registration by a big number of nodes towards one PAN coordinator, for example. It's better to randomize the transmission of beacons, which is, by the way, already supported by the G3-PLC stack. But outside the scope of the G3-PLC standard itself, it's also good that application layers make sure that meters will distribute bootstrapping attempts over time, right? You want to avoid any type of bootstrapping storm where you would end up with a lot of messages colliding and, of course, leading to failure and not to be able to communicate with these devices. So the same way we need to kind of implement backup mechanisms such as in CSMA channel access, but possibly with durations going from several minutes to several hours, so you make sure that you smoothly basically distribute your joining requests. Also, one good thing is please install the data concentrator first and then the meters, which is important. Also, it's important, I talked before about the necessity to maintain registration association over time, so at the application layer. So it's important to maintain these association also during power outages to avoid any rebootstrapping the whole network every time you have a power outage. So this is also very important to have in mind. So the next slide, please, Leon.
Yeah, Cedric, one question came in.
Yes.
You mentioned data concentrators. One of the questions I received is, what is actually better, a G3-PLC gateway or a G3-PLC data concentrator?
Actually, it's a choice that has to be made with respect to the global network architecture. It's not really a question, it's not really a big, it doesn't make a big difference from the G3-PLC side, but it can make a big difference depending on the wide area network infrastructure you have. If you have to manage 35 million meters point to point from the information system using the communication link to the telecommunication operator, for example, towards the data concentrator, it could be feasible, but of course you have to make sure that your system scales right with the number of devices you deploy. In France, for example, this choice was not made. In France, and it is chose to let's say do some local processing with the data concentrator collecting all the meters, and then once a day or whenever needed, if there's more communication needed for some specific commands, the information system connects to the data concentrator on the different data collected previously by the data concentrator is retrieved and by the information system, right? And you can, of course, in case you need to do an urgent operation, the information system could ask it to the data concentrator at any time, so the application process is forwarded to the meter.
Okay, and another question, Cedric, we received. You mentioned the randomization of beacon transmissions.
Mm-hmm.
Is that something that can be controlled by utility engineers?
So
after it has been deployed?
Yeah, indeed. For the beacon transmission in G3-PLC, the default value is 12 seconds, I think. So this is something, of course, it's an attribute you can change. Of course, the issue is that if you have meters that cannot be associated because the beacons can not come through, then you might have a problem to solve by changing the parameter, physically going to the meter and change the parameter, maybe with a local communication port. But if you have a network that still forms without forming in an optimized way, you could of course change this parameter for better operation next time.
All right. I hope that clarified, and otherwise we can answer some questions about that after the webinar, maybe in more detail. Moving on with the presentation, Cedric.
Yep.
There was one other question we received upfront having to do with the attributes and settings for performance, I believe.
Yeah. So indeed, DLMS COSM exposes a lot of attributes and settings. So you can do a lot actually remotely. You can change a lot yourself. Nevertheless, we made all our, all what was possible to avoid any that communication breaks if the wrong parameters are used. So, but nevertheless, optimized settings are suggested in user guidelines we are in the process of publishing, and also default values that are in the G3-PLC spec are in any case recommended. If of course you need to, you want to further optimize a G3-PLC operation, you should definitely discuss that with your product manufacturer to see what can be tweaked without taking any risk or by avoiding any unexpected behavior. But that's of course valid for any technology. Changing parameters is something that needs to be studied quite carefully. In the lab, you can, by the way, do a lot. You can take a lot of risks, try a lot of different things, but once you're in the field, it becomes a bit more touchy, but you have the ability to configure, yes. Also for the routing, more particular, it's influenced, of course, by the different key attributes which have an influence on the routing metric. So you could also here change things, but again, doing it carefully and with manufacturer, and possibly taking into account experience that has been reported in the user guidelines is recommended in any case.
Okay, Cedric mentioned about the user guidelines a couple of times, and explained we published a couple of user guidelines already, and some other are in the process of development. There is one more general user guideline which is available for everybody on our website, and I think we will share that with all of you together with the presentation. And for some other user guidelines, only the summary, the executive summary, is available for non-members. But for example, many manufacturers are member, of course, of G3-PLC Alliance, so they have access to all the user guidelines for G3-PLC. And I will share the link as well together with the presentation after the meeting. Another question, Cedric, we received before the webinar is about certified products and how they are tested and whether they are all tested in the same way. An interesting question, I think, Cedric, you can probably answer.
Yeah. So first of all, as already said by Leon, by Mark, certification guarantees conformance to the standard, interoperability between certified products, and also a specified and minimum performance level that are shared by all the devices certified by the G3-PLC Alliance. So they all have the same minimum performance level. And if you want to go a bit further in what these performance levels are, because manufacturers could have higher performance level than what is expected, you can always ask them for the PICS, so PICS, which is a document saying that that's related to the certification and what the results are, or also asking manufacturers for additional information they could provide and why the product of manufacturer A is better than manufacturer B. So that's the principle of competition between different manufacturers. But G3-PLC Alliance certifies a minimum performance at in any case. In addition, there's some guidance that's provided in the ETSI document, which is that ETSI Technical Specification 13909. You can find it on Google. It's downloadable free of charge. And it shows how PLC products could be tested in the lab to understand how they perform. I mean, with respect to how they handle attenuation, what's the maximum attenuation they could handle, what's the maximum attenuation they could handle also in the presence of noise. Either you have the resources and the willingness to also try to do it yourself in your lab, or you could also maybe ask manufacturers about additional information using ETSI 13909 performance metrics if you want to get more information in your RFPs. So that's what we can say on that specific topic.
Okay, thank you, Cedric. I think that answered most of the questions we received before the webinar, and then I think we can move back to part of the presentation we prepared. We prepared 2 slides about enhanced grid operations. We mentioned a little bit before. Could you briefly explain, please, Cedric?
Yeah, so also this is also to show that G3-PLC is of course used to retrieve data from point A to point B, collect meters in our smart metering use case, but you can also do much more, and that comes, let's say, for free, because if you can also process data from the meters and more specifically information about how meters are communicating to each other's neighbors. We call this information is basically contained in neighbor tables. You could use this information to do much more than just data collection, data reading. You can detect power outages in some localized areas. You could also have a better idea of what your grid cartography looks like, what meter is connected on what feeder. You could also detect the phase each meter is connected to. So these different features again come for free with G3-PLC, and it's purely software based. So there's no additional devices that need to be installed in the grid. So thanks to the nature of PLC that are using electrical lines for signal propagation, you get a lot more information that you would get with any other communication technology, right? So here really the key is do data analysis on what you can also learn from a G3-PLC communication data in the different meters and devices. So that's one of the benefits. And on the next slide, so on the next slide, for example, you could see what was achieved with a grid cartography consolidation use case, where on the left side you see different meters that are communicating with each other. The gray lines are basically communication that happened between 2 meters, and you can of course analyze this, make statistics, and then if you, for example, try to compare it with the information you have, for example, on your existing cartography data, and in that example, each, a meter belongs to a group that is linked to one, that is connected to one, or yellow meters, for example, are connected on the same feeder. And here you say that if you compare the data obtained from G3-PLC and the one you have, you see that there are some errors, and you could correct them using G3-PLC. So actually, G3-PLC helped us, or helped Enedis, to basically correct some cartography they have, and which was, of course, of big use when you have something to repair on the grid, something to maintain, right? So a lot of added value. Okay, thanks.
Yeah, thank you, Cedric. I hope that clarified. And then I think the last topic we want to address from our side in the presentation is regarding the latest development in the G3-PLC Alliance is that we are developing the first standard for PLC RF hybrid communication. And that's being developed in the technical group, Cedric, you are heading. So please, could you explain a little bit about that?
Yeah. So here, also this is a trend that could be seen in the world of PLC, in the world of smart metering. It has been always a struggle between technologies, which technology is the best one to cover a certain use case, smart metering namely. So G3-PLC fights against other PLC standards, also against other RF standards to say who is the best technology. But maybe there's also an alternate approach that consists in saying that technologies could be used in a complementary way, so not competing against each other, but basically taking the best from the two worlds. And here we take the best of the G3-PLC world and from the RF world by allowing the construction of a hybrid network, a hybrid mesh network, where each link could be either negotiated dynamically using PLC or an RF link. And we have developed a solution based on 802.15.4, which is a well-known RF standard, to propose a backup link to the primary communication standard, which is of course G3-PLC, and that would help, of course, to maximize coverage and resilience of the whole grid. And again, the selection is done automatically in a completely transparent way with respect to the application layers. You don't have to worry which link to use, it's done automatically. This is what makes the solution hybrid, and that makes the hybrid solution different from a meter that would embed, for example, two different modems that you would have to manage anyways. Also, one advantage of this, beyond let's say the enhancements that you would get from a coverage resilience and even collection performance, that enhanced collection performance, would be that this favors a lot of new use cases beyond smart metering. You would also be able to connect RF-only devices to this network. You would be able to probably do much more, because while you would use the grid for communication on meters that are on the same grid, you can maybe interconnect this with devices that are located in totally different locations. So we are working on that. A first specification is now ready and completed, and we are now in the way to demonstrate interoperability and to prepare a certification process. So to basically bring this concept, this hybrid concept, to an industrial solution that could be deployed. And I think it would be of very nice to deploy it in new, let's say, in new rollouts, or also in addition to existing rollouts, because this solution is completely backwards compatible with any 100% G3-PLC network. So that's also something we need to mention here in this webinar.
Yeah, and then on your next slide, Cedric, you include the stack you're working on.
Yeah, indeed, this is the protocol stack, what the protocol stack looks like. So just to say that we added the lower layers of the RF channel. So with 802.15.4 2015, the standard for the physical layer and the MAC layer, and we are having operating now in A63, 870 megahertz band. Of course, additional bands could be added in the future, and all the switching between PLC and RF is decided in a dedicated layer, which is called hybrid abstraction layer, just below the 6LoWPAN layer, adaptation layer, which will allow let's say this hybrid solution to completely integrate into the G3-PLC stack we know of today. And the rest I've already mentioned it in the last slide.
Okay, I hope that explains a little bit about the hybrid PLC RF solution we are currently working on. Before we have to close the webinar, I think there's one question, Cedric, I hope you can briefly address. That is a question having to do with the network and the network. And it is, if my network has a lot of joints in it, is it advisable to use G3-PLC? Wouldn't there be a lot of impedance for the successful use of G3-PLC in such a network?
So the question is being if there's a lot of joints, right? So oh, you mean physical network joints?
Yeah, I think that's what meant. Yeah.
I wouldn't expect that the presence of joints would significantly affect propagation of PLC, because at the end, what really affects PLC it's rather the impedance of custom loads and number of custom loads and density of custom loads. Of course, joints could have technically a little effect, but I would not think that the little effect of these would significantly change, let's say, the ability of G3-PLC to communicate, right? So I wouldn't expect any issue here.
Okay, thank you. So we have a few other specific questions which we will answer later directly with the people posing the questions, because they're quite specific. And as we are approaching the end of the hour we reserved for the webinar, we'd like to come to the end. We hope we answered your questions about G3-PLC, and you will agree that G3-PLC is a powerful communication backbone also for the African smart grid. G3-PLC has proven robustness. It's designed for harsh network conditions. It can enhance your grid operation to address key critical processes in your organization. And we are working on advanced technologies like hybrid communication. Like I said before, we have many members in the G3-PLC Alliance, and the members, they work in different working groups in the Alliance to help in the marketing, to help in the technical enhancements of the G3-PLC technology. We have different types of members, and we also have members which are more into R&D and training, and these you can also find these companies on our website, which could help you in training for G3-PLC or doing specific analysis if you would need that. To conclude, we want to thank you very much for joining us today and for sharing all the questions. If you have any further questions, please contact me or one of the other panelists, and we will be happy to answer your questions or to organize a follow-up discussion if you want to. Like I said, we will share the presentation, and after the webinar, I hope you can take a minute to complete a short survey after the webinar. Thank you very much, and we hope to meet you again soon at African Utility Week in November, hopefully, or some other time soon. Thank you very much for joining us.
Thank you. Thanks a lot.
Thank you. Thank you, Leon. Thank you, Cedric. Thank you, everybody.
Bye-bye.
Goodbye.
Goodbye.